So today we are going to start this Leetcode question and let's begin. Okay. So today question we have 1443 and minimum time to collect all the apples in a tree. So this is given a statement. Statement is saying given an undirected tree consisting of n vertices, number from 0 to n minus 1, right? So if n vertices is given and it is saying 0 to n minus 1, which has some apples in their vertices, right? And you need you spend 1 second to walk over one edge of the tray and return the minimum number of seconds you have to spend to collect all the apples, right? Minimum time in second you have to spend to collect all apples in a tray starting from index 0 and coming back to this vertex. Means you have to use DFS like that. Okay. Yes. So it is saying we have given n vertices, right? And it is from 0 to n minus 1, right? And what we have to do, we have to we have some apples and then we have to spend 1 second to walk over one edge of this tree, and we have to return the minimum time in second you have to spend to collect all apples in the tray, and that is starting from 0 and coming back to this vertex, right? So the edges of the undirected tree are given in the array, and where edges of I, a of I, you can say here edge of I is b of I. That means exist an edge connecting the vertices a of I and vi, and there is a boolean array has apple I is true, means I has a apple, otherwise it doesn't have an apple. Let's understand. We have example 1 we have given, right? You understood the question, right? So this the edge is undirected tree. Okay. So as we have given n equal to 7, means we have 7 nodes 0 1 2 3 4 5, like that. 0 1 4 5 2 3 6. Okay, 0 to 6 we have given, and edges is like that. 0 1, it is 0 and 1 is connected. Now 0 2 is connected. Okay, fine. Then we have given 1 4 we have connected. Yeah, it's connected. 1 5 is connected, and 2 3 is connected, and 2 6 is connected. As per the given edges, this tree is given, right? Now we have has apple, means at here, and at here. Let's assume the index 0 1 2 3 4 5 6. Let's see the edge of the here, right? We have at edge 0 1 2 3 4 5, right? Total how many edges we have? N minus 1. If n is equal to 7, means edges, number of edges should be what? N minus 1, and that is 6. N minus is what? 6. That is our edges, that is 6. Yeah, it's good. Now 0 to 5 is 6, and total node is 7. Now we have has apple given, right? At each node we have given. So 0 1 0 to 6 we have, means to all the edges we have, right? So if we talk about here, right? So at first node, right, if we'll talk about the node 0, right? Node 0 is 0, like this, and we have what? We have given another 1 2 here. We have apple here. We have at the red mark, you can say we have the apple. Now we have to figure from the above figure. What we have to do, we have to see the red vertices have an apple or not. So the optimal path to collect all the apple is we have shown. So how we will find the apple? So as you can see, we have to go first this row arrow, right? And you have to count actually all the green lines, right? So if you count the green lines, 1 2 3 4 5 6 7 8, right? So we have collected all the apples, right? As we will traverse like that only, and so it is returning 8 as an output. Okay, so for traversing 0 to 1, it takes 1 second, and so that it will take total 8 second it will take. Okay, as per the green line. Okay, green line is he is traversing from one node to another node, right? On the you can say through the edge, and each edge will contain 1 second. So total he is containing 3 apples, 2, 4 and at 5, right, nodes, and the green lines, if you count traversing count, so it will take 8 seconds. Okay, I think you have understood the question. If you talk about this one, similarly we have what we can see, 5 and 2, we have 2 apples, and if you'll count the green lines, 1, 2, 3, 4, 5, 6, so it should return 6 as an output, right? That's all we have, and let's go to the coding section. How we'll define, how we'll implement this. Actually, what we can do, this is the best approach, DFS, right? Depth first search for the tree traversal, right? This is the tree traversal algorithm, and we have seen many videos on this one, right? So what we have to do, we have to start with one node, right? Let's suppose 0, and then we will traverse here, right? Then we will traverse down, and if we find at this location, right, apple, then we have to count the path. So first we have came here, right, the green one, white one, then we have came 2. After coming to here, we have to go back to 1, right, then we have to go to here, right? So you can say, coming to 5, we have taken 2 counter, and going back to 0, we have to update 2 counter, right? So 2 coming and 2 going back, right, return back. Total it count what, 4, 5, reaching to 5 apple, right? It will have 4. Now coming to 2, he came with 1 second and going back to 2 second, so total 2, he has got 4 apple 2, right? And total it will count, it is total 6 second. Like that we will do in the DFS. Okay, so let's go to the browser and we'll do implementation there in the code. Okay, so we have, what we have given here, we have given n number of nodes in the examples. As we have given and has apple we has given, right? So this is the function meantime. We have to return the minimum time to return all the collect all the apples, right? So first of all, we should always create our adjacent list, right? I'll give adjacency list. Okay, this adjacent list, we can say that this is our map, right? We can take has map, new has map. Okay, we'll take. So this has map should be what, we can say map, and it will take two things, key as integer, right, and integer as a value, right? Our map is ready. Adjacency list is ready. Now we have created. Now we will initialize our adjacency list, and we'll have, we will get from what, our edges. Now edges is given this, right, and these edges is what, one by one we will get edge like this, right? We'll get all the edges from here. Now if we get one edge at a time, right, so two node we will get at a time. Let's we'll say node A, we can say node A will get from what, we have given edge, right, edge at 0, correct? Similarly, int node B equal to edge at what, 1 we have. So two nodes we have now, node A and node B. Now what we have got from the first edge, let's assume. Now adjacency list we have, this adjacency list will do compute if absent, right? If absent, we have to, sorry, we will pass our first node, this one here. Okay, and then we'll say that we used to do what, like this, we can say array list, and then we will pass, it is a type of integer, and we will pass dot, we'll take the we have to initialize, right, like this. Okay, now this is done. Now we will do the add, right? We will add node B. Okay, similarly we'll do copy, we'll add for node B, and we do here if it doesn't have adjacency list, right? Now this is done. Both is done, right? Node A, node B is if absent, then we will add on to the adjacency list. If we have already, then it's fine. Now we have initialized our adjacency list and we have added all the value here, right? This is another approach also, you can initialize, right? But it's okay, fine. Now we will do return what? Our DFS utility method. DFS utility method, and this method will pass the node 0. We'll start from the node 0 and its parent is -1, right? And we'll take our adjacency list, right? This is our adjacency list, and we have to pass has apple function, sorry, value list, so that we will traverse only to find the has apple, right? So three things we have passed, right? Now what we have to do, we have to create this function exactly as we have given. So how we'll do that? We will say public or private, you can say int, and then we'll pass dfs utility method, and this is the body of the function. So n is what we have root node, so that is called node, okay, and this is what parent, -1 is what int, we'll say parent node, and this is the map. So I'll go from here, I'll get till that, okay. So this is our adjacency list, and has apple is what? Boolean has apple. So this is our boolean has apple. Everything is done now. So first we will check if this adjacency list, if this adjacency doesn't contains, right, doesn't contains key, sorry, contains key what? As a node. If this node is not in the list, means we will return 0, means no need to go further, right? If that is not the case, we will take some variables. We'll say total total time to get apple, है ना? Total time to collect apples, right? Total time to collect apples we have taken, and we'll start from what? 0. Now another will check in for all the uh, uh, childs, right? Child, we can take a child time, okay. So I'll take this total time to collect apples from what? Child tree, from child tree, child sub, you can say subtree, okay. First child subtree, child subtree, from child subtree we have taken two variables, right? Total time to collect the apples from this one and this one, okay. This will I'll take a 0 2. The variable is little big okay. Two things is done. Now we will move to all its kids, all children. All right. How will go that? We will have our adjacency list, right? This adjacency list we have, right? And what we will do? We will go to its node, right? How we'll get that? We'll do get, and we'll call. We'll pass the root node, right? Starting we have root node, right? If root node have its child left and right, this is called our child node. If children child nodes, we can say child node, right? If any of the child node we have, or left or right both children have, then what we will do, we will make a condition here, and we'll say if child node equal to parent, right? If child is node is this one, we don't have to do anything, we will skip this one, okay. And then our child time we have to update this one, okay. Total time collected by child, right? So rather than doing big one, I'll take total time, rather than this one we will make the small like this. Okay, so now we have updated variable. Okay, so value this value will come from what? Our recursive function of DFS. We will do recursive call for all its children. First we have child node we have, right, that we have got here. We have child node, and then we will pass what? Then we will pass its parent root node, and then we will pass uh, adjacent list, right? Adjacent list, and then we will pass what? Has function, right? Has apple. These three things we will pass. So if the child is greater than 0, we will indicate that tree is has some apples, right? Since the root of the subtree node doesn't contribute to the time, and even if the child apple have, then we have to check independently, right? So if we'll talk about how we'll do that, if we have child time, we already have, we have calculated this child time. If the child time is greater than what? 0, or right, what we will do, we will have our has apple, right? This has apple we have greater than 0, or if we have our node, child node onto the has map, right, on the has apple, then what we will do, we will update our time like that. How will do that? Equal to the time plus 2, right, going and coming back. Sorry, this will be our total time. This is our total time, because if it is greater than 0 means we have to go and come back, so that we have to do plus 2. Initially we have what? 0 value we have, so each time we have to add, for each sub children we will add 2 for going and coming. 2 seconds we will add 2 seconds for going and coming back. Okay, this is done. Now what we will do, before after the for loop, right, we have to return our time to collect all the apples, minimum time to collect all the apples we will return, and this is our mean time. Okay, let's run this program. Hello guys, so here we have to update our adjacency list, because each node will contain a list of integers, right? So that we have to update, and this will go to the DFS utility method, so that we have to update here also in adjacency list, right? We will take integer and then list of integers, so that each node will have a list of its neighbor node, right? And that's all we have to update. And if we'll run this program, so it will run. Now we have to submit this program. Let's submit this. Oh wow, thank you so much. Okay, so this is working fine. So if we'll talk about the DFS, right, that time complexity already you know, right? So we have discussed multiple times, right? If there is n number of nodes, so time complexity remain O of n, and for the space complexity we are taking extra spaces for the store the urgency list, right? And that's why we can say that we visit all the nodes, and we will to store that nodes onto the urgency list, and so that time complexity and space complexity remain O of n. Okay, thank you so much, thank you so much. Please hit comment and like the video. Thank you so much.